Okay, 5-7 is actually Photomath's favorite way of, and actually most AI solvers, it's their favorite method of factoring. And the thing is, we always look at it and we laugh because they take really simple problems and then they factor it by grouping. They actually make the problem more difficult. So we're not going to do that. We are only going to factor by grouping if the problem lends itself to factor by grouping. So factor by grouping comes when you have 4 terms. Your highest term is typically a cubic. That's what we're going to use it for. But if I have 4 terms and it's a cubic, I can try factor by grouping. And the reason being is if I factor by grouping, I don't have to do synthetic or long division to find the other factor. I could just do this. Now this doesn't work every single time, just like factoring. We can't always factor a trinomial or something. We might have to do a quadratic formula or something if we're solving. But it's worth trying because it works really quickly. So this is how it works. Basically, you look at it. Do I have a greatest common factor? I do not. So I draw a little line coming down. Right in the middle, right after x squared. I leave the sign attached to the x. Okay, so I cut that down the middle. Then what I do is I take the greatest common factor of the first 2 items. So my greatest common factor here is just x squared, and then that leaves me with an x plus 7. Because if I would multiply this out, I would get what's directly above. You with me? Okay, nothing too crazy. Then I go to the other side and I treat it like a brand new problem. And I go, what's the greatest common factor between negative 4x and negative 28? And you can answer 4 or you can answer negative 4. And this is what I mean by that. So I would put my parentheses. And the thing is, I need to play a matching game. I need x plus 7 to be in that parenthesis for this factor by grouping to work. So if I look at this, do I want to take out 4 or negative 4? And I want to take out negative 4, because when I take out negative 4 times what is negative 4x? Just positive x. And when I go to the next one, negative 4 times what is negative 28? Positive 7. So then I now have matching pieces inside my parentheses. So if they match, I always say it's called factor by grouping, because then I take those things and I group them together. So those 2 things become one thing. And so I get x plus 7, and you only write it once. Those 2 groups become this one thing because they match. If they don't match, you can't do factor by grouping. So I got this. And then I take what's on the outside of my parentheses, and I put those 2 things together. So I get x squared minus 4. And I'll put a little star here, because that's the factor by grouping. So factor by grouping is done. That's it. This one line. Okay? 1 line of work, 1 line for the answer. Nothing too crazy. But are we done factoring this? No. What's it keep factoring to? What factors again?
You can factor the x squared minus 4 into x plus 2x minus 2.
Perfect. So we have the difference of perfect squares. That is the item that shows up the most in terms of when we factor in that it has to keep factoring. So I get x plus 7, and then I get x minus 2 and x plus 2. And you can flip-flop that order. But that would be factored completely. Question? Number 2, I do the same thing. I look for a greatest common factor. Do I have a greatest common factor? I don't, so I'm going to kind of gloss over that fact for a moment. So I draw my line down, and Chase, what's my GCF out of the first 2 terms?
X squared.
Okay. Good job. So we got x squared, so I get x minus 6. So x squared times x gives me the x cubed. X squared times negative 6 gives me the negative 6x squared. So then I go to my next piece. So Asher, what would be my greatest common factor between 8x and negative 48? Perfect. So I take 8 out. So I'm going to have x here, and then my no calculator friends, since they've been thrown away from us. 8 times what is 48? 6. Fair game. So I'd put a minus 6. Look at that. Matching. So we got the matching set. I want you to try to put it together. And then we're going to compare and see if we got the same thing. Can you factor that further? No, you can't. So that's it. It's done. Questions? Take a look at number 3. So number 3, does it have a greatest common factor? It does. Aiden, what's my greatest common factor? 8x is perfect. So I'm going to take an 8x out. So basically I'm changing this to factored form. And, you know, there's a lot of things that this happens in long division, it happens in synthetic, it happens here. But if something starts in standard form, when you perform that operation, the result is also in standard form. So when I look at this, this becomes x cubed. I'm going to just go down in order and put x squared and then x and then a constant. So I don't even have to really think too much about that. However, I can check that pretty quickly. So I go 8 times what is negative 16 x cubed with the x attached here. That's going to be a minus 2x squared. That makes sense. It's going down by 1. I go to the next one. 8 times what is 56? The last class told me 6, even though we just said 48.
7x.
All right, so we got 7x. And then our last one is just 3. Now I drop the line down. And I factor out what I can. And this gives me x squared and then x minus 2. When I look here, what's my greatest common factor? 1. Okay, you always have a factor of 1. Okay, you always have a common factor of 1. However, that does not mean we do anything with 1, because if it's just 1, it doesn't pay to take 1 out. Like, it doesn't do much. However, it's worth noting that if we try that, I take 1 out, I get 7x minus 3. Do those match? No. I cannot factor by grouping. That is my answer. So we try to factor by grouping. We hope we can factor by grouping. But it does not mean we are going to be able to factor by grouping. Okay? Questions? Greatest common factor for number 4 is just x. So I'm going to put an x here, and I'm going to change it and write it like this. And then you are going to factor this by grouping for me. And this one does work. You got to take a little bit of manipulation along with it, though. So you look at the first two terms. How's your greatest common factor for the first two terms? What about the x? How many x is going to take over? So put x squared on here. So then that means inside, I would just have x minus 4. Because I'm taking x squared away from each of these.
Okay.
And
So this one,
you can just start by writing this line. That's going to help you see what you can take out. And we're actually going to finish them or not. But that's how you look at it. You look at the first two and the last two.
okay.
All right, so folks, as I walked around, a lot of us were decent at this. But then we got to this last part and we're just like, it's not looking like it's working out. Well, here's the deal with that. So I can take a 1-0. But I can also take a negative 1-0. So if I choose to take -1 from both of these items, this becomes -1. This becomes a positive x. Basically, it just flips my signs and I get -4. And then I close that parenthesis. Now I have brackets here just to remind myself that I have this x on the outside yet. Okay? So now I write it one more time. I get x. And then I get an x squared minus 1 and x minus 4. Can I do more with that? Do I have the difference of perfect squares? I do. Because 1, I know the square root of that. The square root of 1 is 1. So actually, this piece right here, I can write it again. And so I will have x minus 1, x plus 1, and x minus 4. So that would be the complete factored form of that. Questions? Then get out the sailing sheet of paper. So that is factored by grouping. That's it. There's nothing else to it. Okay? You have opportunities to practice that. But right now we're going to practice a little bit of solving. So jot this problem down. Looks terrible. Looks terrible. But it's actually not terrible. It's pretty easy. And I'm going to help you with this one, and then you're going to do the next one on your own. And if you do run out of pieces of paper, you can always grab another one. We've got plenty. First thing you always do, if possible, factor. So I'm going to try to factor this if I can. Nothing factors here. I can factor here though. There's a greatest common factor of x. So I'm going to rewrite this. So I can take out an x, so I get times x, and then I have 3x plus 5 left over. And then I have the x squared plus 25. Why don't I factor the x squared plus 25? I can't. It's not the difference of perfect squares, it's the sum of perfect squares. We don't factor that. Okay? So that's what it's at. Now you could also change this. Instead, x squared times x is just x cubed. So to save myself a little bit of solving time, I'm just going to write it as x cubed. So that's the simplified factored form of that lovely problem. remember, if this is equal to 0, I set every piece equal to 0. So negative 3x cubed equals 0. What's x have to be? 0. Yeah. 3 of your solutions are simply x equals 0. We can go through that. I was hoping we wouldn't have to. But if I solve this, well, I divide by 3, I get x cubed equals 0. There's only one option, right? There's only one thing it can be. But you could take a cube root, you'd still get 0. So that's that. We go to the next one, I get 3x plus 5 equals 0. A little bit of work to do there. You do the work, give me the answer. What'd you get, Mason?
I got x is equal to negative 5/3.
And negative 5/3 is perfect. Now, some of you might be tempted to go ahead and try to give me a decimal. That temptation is no longer present when your calculators are gone. So keep your answers as fractions. Last one right here. So this one gets a little tricky because when I take the square root, what is the square root of negative 25? Asher, what's the square root of negative 25?
4 minus 5.
I.
I.
Yeah. All right. So the square root, remember, whenever you got a negative, you can tack the I on. And whenever we take the square root, we have to do a plus or minus. Okay? We have two solutions because it's an x squared, so the plus or minus is what helps you out. So I now have all of the solutions to this problem. So think about truly how much work there is there. This one, eventually, hopefully, our goal is that you see this and you go, okay, that's 0. I don't have to write it out 3 times. All right, you can write x equals 0 and you're good. But then this next one, yeah, you can show a little bit of work, but I mean, 2-3 steps, nothing too crazy there. And then this last one, the square root of 25, that's also a pretty quick one. So nothing too crazy in terms of time. Questions about it though? This one's all you. And I'll tell you right now, every single thing factors up there. No need for a quadratic formula. I'll give you 2 minutes. that is time. This factors to, well, we have 2x, and then it goes to x plus 4, x minus 4, and then x plus 2, x plus 1. And then my solutions just become 0, -4, 4, -2, -1. Thoughts, questions, wonderings? Write it down. We're going to do both synthetic and long division. So I'm going to have a little bar coming across here. I'm going to put my factor on the outside here. And I'm going to put my function on the inside. So we're going to just start with long division. So on the quiz, we did okay with long division. We had pieces where, half of what we did was kind of right, but we just didn't get all of it right. And the thing with long division is if you make one little mistake, then it just keeps compounding and compounding, and there's no way in heck you're going to get something right. So when we'll compare the differences once we do the synthetic. So long division starting out here, I have my factor on the outside, I have my function in the middle, and I'm looking to find my quotient. That's what our quiz was doing. So I'm going to look for what is up here. So I start, and with long division, it's really important that you're very organized. So you will notice that when I'm doing this, I follow columns and rows. There's like a grid there, and I go through the whole thing. So I start off, x times what is x cubed? Just x squared. So I put that down. I like to go in that column, but it doesn't really matter. You can go right above the cube. And then I go x squared times x is x cubed. What else do I do? By the way, I also have to do what? I also have to multiply this x squared to the -5. So what you need to think of, it's like this. I am distributing to both of these things to get this line right here. You distribute every single time to those pieces. So I'm going to get rid of this space-wise. And then I multiply, and I get -5x squared. Now, another place that we made mistakes was we were very good at saying, okay, this cancels out. But we got to remember why that cancels out. It cancels out because we matched it, but then we flipped the sign. So if I flip this sign, I also need to flip that sign. And we forgot to flip that sign. Okay? So once that sign's flipped, this gives me 3x squared. And then I drop down the -11x. So what do you go, x times what is 3x squared? 3x. And so like I said before, things in standard form tend to go in standard form. This probably is going to continue in standard form. So it makes sense that the next thing I multiply by has an x. Because I went 2, now I went to 1. Now it's going to be a +3, so I put my plus sign there. And I distribute to the two items in the front. So I get 3x squared minus 15x. What do you do now? Flip the signs. So I flip the signs, minus, plus, cancel, and this gives me 4x. I drop that 20 all the way down. So I just multiply by 4, and so that gives me 4x minus 20, and then I flip both of my signs. So if you are working on your quiz, if you did this problem well, if you're looking at the corrections, you can use this as kind of a guide as how you're going down. So this cancels, and I get 0. But let's say I had 2. If I had 2, then I would put a plus sign and put 2 over x minus 5. I don't have a 2 there. I have a 0, so I don't have to put anything. But that's what we would do if we had it. So that is my quotient. Questions on long division? Synthetic now. So I got 1, -2, -11, -20. I'm going to put 0 right here because I already know that I'm going to get 0 as an answer. So we can speed through that process. What goes out here? +5. So, this is where a couple of mistakes were made. The difference is right here. Factors versus solution. Factors versus 0. Okay? So, you gotta realize that when we are looking at what goes outside synthetic, it is whatever makes this 0. So that's 5. I also could have gave you x equals 5 and then asked you to go backwards and figure out what that factor was. That would give you that solution. But we didn't. That's what we started with. So I have this. And then I go ahead and I drop the 1. Now the issue is some of you were dropping the 5. Which I don't actually care about too much because at least you knew to drop a number. But we drop the number on the inside. So we drop it down. And then we go through this process over and over and over again until we're done. We multiply, we add. We multiply, we add. And you just keep going like that. So if it's outside, I multiply, and I get a 5. Inside, I add, so I get a 3. And then I multiply, and I get 15. And I add, I get 4. And then I multiply, I get 20. And I add those up, and I get 0. Now, if I'm asking you for the quotient, you have to write that out. You're not done here. You have to write this as x squared plus 3x plus 4. That's your answer. Now, if I change the premise of the problem, and I ask you, let's say this function is f of x. If I ask you what is f of 5, what's f of 5? 0. So if I'm asking you to do synthetic substitution, you have to do synthetic division, and you have to just give me what the remainder is. I don't want anything else. If you give me the other stuff, you're showing me you don't know what it's actually asking for. So you have the comparison between the two. Obviously, synthetic is way nicer, it's easier, it's faster, it's quicker. Pretty much everything about it is better, except for the fact that I can have 3x minus 1 out there and I can figure out what that is. Right? Synthetic, we can't do that. What questions do you have? When you finish your quiz corrections, if you work on that, are you going to turn them in the basket? No. You're going to show me and I'll get them back to you. I want you to actually go back to your note packet for a moment. And can I steal your note packet? I want you to find 5/8 and go past it. Yeah, can I steal your packet? Thank you. Alright. So you have, when you get past 5/8, there's this sheet of paper. It does not have a single lesson name on the top. It says Super Convenient Factoring Reference Sheet. You are allowed to use this on any Chapter 5 quiz or test. This was planned. Okay, it is. I don't feel bad at all for making you take a test without a calculator, but I am kind of nice and I gave you this instead. So you can factor all these problems. You can't write anything else. Like if I walk around and I see long division on here, yeah, you're done. If I see synthetic, that's not a good thing. Okay. And on the back of this, it even tells you this side should be blank. Okay. Nothing's on it other than what's printed on it. So you can factor all these things. And I will tell you, yes, this is correct. Or no, this is incorrect. But I will not help you. Okay?
So I'm letting you use this on the test. Thank you, John. But you have to be the one that puts in the work. You can go on the MRC, and they might help you, but if I'm sitting in there, I'm not going to help you, okay? So in class, I will check it. I will say, yes, this is correct. You're good to go. Use it on your test. And do you think that those are going to be the questions on the test? No, but you're going to have examples for you. And actually, one year we did, and I still had like, Schmeling and I looked, and we had like 40% of kids got that problem wrong. And we're like, it was on your sheet. Like, it was literally right there. So chances are it's not going to be on there, but there might be one, okay? So just, if you want to do that during your homework time, you can do that. You can do quiz corrections, you can do homework. There's one thing on there you haven't learned, which you will learn tomorrow, but that's only one problem. All the rest of them you can do. So, the time is yours.